opportunity to tell us something about what happened 40 years ago. I think I have about 30 minutes, right? Yes. To tell what happened in 40 years in 30 minutes. It's probably I could not say very much, but technically I would not say very much about it, the technicality of it, because you all here who are here probably well known about this accelerator technicality. But what I would like to tell you that how we set the goal and how we set the plan, how we set the strategy to achieve the goal we were aiming at the time. I had been a fighter for 30 years. You know what a fighter is, you know, fighter who fought everything, fought everybody, tried to get what his group wanted. And after 30 years, I become a promoter. You know what a promoter is? A promoter is one who try to promote people, promote projects to be developed. And now I am an advisor. This is very good advisor because being an advisor, you do nothing. You just sit, and if nobody asks you, you don't have to say anything. You only say what they ask you, and you don't care whether your advice will be taken or not. So you are very, very happy, and you don't have to worry about anything in the world. That's what I am now. And I would like to take you back to 2022. 2022, that was what, 40 years, just 40 years ago. At that time, I came back from the United States after spending almost 5 years in the United States. I came back to an empty lab, laboratory. Whether in Chiang Mai or in Bangkok, there is no single research laboratory in the whole of Thailand. Believe it or not, the only paper that were published internationally at that time were from a group by Professor. You know, Professor Virun Sayakanit. Anybody come from Chulalongkorn University? Yeah? No? Well, it's a pity because at that time Professor Virun was a theoretical physicist who could publish in physical review. You know, at that time, it is harder to publish paper in physical review experimentally than to win a รางวัลที่หนึ่ง lottery ticket นะ that was the case, you know, because there was no single equipment. You need, if you are experimental physics, you need to build equipment. So what should we do at that time? So basically, I was trained as a nuclear physicist. As you know, nuclear physicists, you have to shoot nucleus, you know, and you need a probe to shoot nucleus. Well, a probe, see, there we want to explore nature, and we need tools to to understand nature, especially physics, because we live in a very large, in terms of space and time, very large and very small. Now, to probe nature in space and time, you need 5 fundamental probes. You need neutron, ion, electron, or photon, and of course, plasma. But these are the 4 fundamental probes that you need if you want to probe nature, especially if you want to do nuclear physics. So, how do we produce this probe? Well, you need accelerator to produce the probe. Whether it is a SEM scanning electron microscope, you need an accelerator to accelerate electron. So, an accelerator is very simple in structure. First you have to create ion or electron. So these are called the ion source or electron dissector. And then you have to give it a push, give it a kick, so it has enough energy. Whether it's a KeV, MeV, or BeV, or TeV. And then you have to transport the beam. When you produce electron ion, it come out in all directions. So you have to be able to control them and then transport the beam and focus it onto the target chamber. This is where your target is and where you shoot the beam into the target, whether ion, electron, or even photon. Now, you need power supply, whether it is a DC direct current or an RF to give the ion, electron a kick. And then, of course, it's not scattered, so you need a vacuum pump to pump it down to, normally at that time we use about 10 to the minus 5, but now if you ask the synchrotron people, synchrotron radiation people, they have to pump it down to what? 10 to minus 9, 10 to minus 10, okay? So these are the basic things. And at about that time, the world's first accelerator, actually it was, the concept was developed by Gustav in about 1924, something like that, around that time. And then later on, Rob-Villero, he built the world's first LINAC, about 88 centimeter long on a glass tube in Germany. That's just a demonstration things. But the real working things come in during the 1991, 1992, during that time. When, for example, when the Graph, he built when the Graph generator, electrostatic accelerator, or a small cyclotron built by Ernest Lawrence at the University of California, Berkeley, or Clock-Walton accelerator, if you all remember. This happened during the 1932. Where were we in 1932, around that time? If you remember, we had ปฏิวัติจำได้ไหม2475 ตอนที่เปลี่ยนแปลงการปกครอง At that time in 1932, the year that they discovered neutron, we in Thailand we had ปฏิวัติเราเปลี่ยนแปลงการปกครอง so we were busy with politics not science at all that's why we were far behind other country but 40 years later on around 228 230 นะอาจารย์พิยโยปัญญารชุน at จุฬาลงกรณ์ University in 2028 นะ 2028 ประมาณนั้นนะครับประมาณนั้น 2028 he built the first accelerator 150 kV clock quantum accelerator but he used it just for display at the science fair but he did not use it to do anything any experiment just to demonstrate that we can build an accelerator at that time at about the same time in Chiang Mai start building the accelerator facility. This is the first compact accelerator. You know, is a sealed tube. It can generate 150 keV to produce neutron from the DT reaction that you heard this morning from the DT reaction here. So around that time. Around say 1980, 83, 84, an accelerator facility was being built in Chiang Mai. Why? Why we build accelerator? Why we need accelerator? At that time there were at Chiang Mai University there were 3 PhD just coming back from the United States. They are on graduate PhD in nuclear physics. Professor ประสิทธิ์เจริญขวัญ Dr. นาราจิรพัฒน์พิมล and me. So naturally, we want to do something that we had learned during our PhD. That we want to do physics, nuclear physics experiment. But to do nuclear physics, you need a probe. So if you use ion, positive ion, you need 100 million baht for the accelerator. But if you use neutron, you can produce neutron with about less than 10 million baht. So, and neutron at that time was very popular. 14 MeV neutron at that time was very popular because at that time they start the fusion program. So fusion, and as you know, 14 MeV neutron carry energy of the fusion into the outside, and this neutron interact with material, the structural material of the reactor. So they need to know the cross section that 14 MeV neutron interact with matter. That's why they want to do cross-section measurement. And at that time, they want to understand the nuclear reaction mechanism also, so that they can use the nuclear reaction model to predict the cross-section that they could not be experimentally measured, right? So that's good. So we decided, all right, we're going to build a neutron generator, 150 kV neutron generator. And so we form a group if you remember someone like Dr. วีรพงษ์แพรสุวรรณอดีตปลัดกระทรวงวิทยาศาสตร์ Permanent Secretary นะ Dr. สมศรสิงหรัตน์และอาจารย์นาราจิรพัฒนพิมล some of you may know so we start this and fortunately we don't have to start from scratch you know we were given a Newton generator here this is a 150 kV machine drive to machine here it can produce about milliamp of deuteron here now the idea is to do nuclear physics you have two time scale either you want to do it in microsecond scale or nanosecond scale okay microsecond scale you just bombard the neutron and then you measure the radioactivity this is measured in microsecond but to do a nanosecond you do prompt measurement you hit you bombard target and then you measure what happens at the time that means you need to have a time that is resolute to 1 or 2 nanoseconds. That means from a direct current machine, you need to bunch it, to pulse it to 2 nanoseconds. Why? So we said we're going to build a 2 nanosecond machine. We asked an expert from Japan, Professor Takahashi. Professor Takahashi said, oh, very simple, very easy. You know, you just chop it into 20 seconds, and then you bunch it into 2 nanoseconds. Very, very simple. I was talking with him over a glass of beer in Kausik in Germany. So I said, all right, can you come and help me build it? He said, yes, I will come, why not, you know, over a glass of beer. Okay. So he did, and he bought the blueprint, you know. Now, reverse engineering of a bicycle is very simple, but reverse engineering of a nanosecond bunch machine, you have to make alignment so that it is straight within 1 millimeter, and you have to transport the beam 10 meters long, and the beam is only less than a millimeter. Now this is not simple at all, you know. So at first we construct it according to the blueprint, and we learn while constructing it. And we have to make modification. We have to do the computer simulation. So here, you see you have a deuteron beam coming out here, and then you have the X and Y plate, you chop it into 20 seconds, 20 nanoseconds, and then you have a bunching tube here. A bunching tube is a tube where you apply the RF. The RF will retard the front part and accelerate the second part until it's bunched to this distance is about 2 nanoseconds. I spent 3 months learning the theory of bunching machine, and then everybody took part in building this. It took us 6 years to do it. Another 2 years to do the spectrometer, Newton spectrometer, until finally we achieve the best 14 MeV Newton facility in the world, better than in China at the time, better than in the US. At the US at that time, University of Michigan was building the same machine. And China was building also the same machine, but we achieved the best Newton time of flight facility with 12-meter flight path. That is the best energy resolution in the world. You know why we achieved that? Because we have a good components. We buy good components from America. But China at that time could not get good transistor, fast transistor and component from it. So this is the beginning. Here, what we have to do is to transport the beam from here. You know the beam when it bend over here, it diverges. It diverges from here. It diverges. You have to be very tricky here. We use a quadruplet. That means two quadrupole connected together. So it's called not a triplet but a quadruplet here. So that you can transport the beam. And then you have another quadrupole here again. So finally, we achieve this nanosecond house beam. But we have not touched anything in here at all, you know. Okay. So once we have received this, we finish this. Took another 2 years to do the experiment, and it take me 13 years after I finished my PhD to get my first paper published internationally. I believe you guys in here can publish internationally within 1 or 2 years after you finish your PhD. But it took us 13 years at that time. Okay, so after that it become easy. The next one is we build an ion implanter. Here you see what we have to do. We have to build a quadrupole magnet here, and then another magnet here. Some of you may be in here who were building this. We have not touched anything here yet. We just build the beam transport system, transport it to the target chamber here. And then one day we push the button. Hey, nothing come out. Now, but what happened? We push that button, you know. Hey, they made too many buttons to push. Nothing come out at all. You know why? We do not understand what ion source, how it works. You know, the whole concept of accelerator. The ion source is the key. You push button and there's nothing come out, you cannot do anything. So, okay. Oh. Alright? We start another one. This time, we build the whole things from scratch. We just bought an ion source. We still do not understand the ion source yet. What it works, how it works. But we build everything here. Now this is the first accelerator that we build here. And then after that, this is a vertical machine we built from scratch again. This one has a very good feature. If you see down here we put an AFM inside. You know, when you operate accelerator, the pump vibrates, right? And if you want to use AFM, you need to be very stable. My PhD student, she stabilized this, and so that they can take the AFM inside the vacuum chamber here. Because biologists say that time scale of 1 second is very long for biology. If you bombard it, take it out, and then look at the microscope, everything changes. You need to look at it in situ. So this is the one. This is an ion source. We still don't understand the ion source yet. But we were lucky. We push button, there is something coming out. Okay, so here's another one, the last one. Is a compact machine that you can use to do many things, to irradiate rice, to irradiate gemstone. This is, we build everything. Also, now I show you another one. This one is an ion implanter. It costs about 70 million baht, but I got it for free. I have a good friend in America. You know, I have to say that to be able to build the whole facility, as I mentioned to you, we, our group, Penny Bunkun, or several people in Thailand, several people in the world, we owe them, because we ask for many things from everybody that we can lay off. Here is a friend from America. He said, I have an implanter. Do you want it? I said, yes. Then I give it you for free. You just transport it. So I asked IAEA to transport it for us. Sorry, this one. And then at the same time, Sawatoshaw bought this machine for second-hand one for 16 million baht and give it to Ladgabang, but it never get to work. But here, since we have experience, we got it to work, and it's still working nowadays. The next one, a friend from Sweden said, hey, I have a tandem accelerator available. Would you like it? I said, how much it costs? Well, normally it's cost about 90 million baht, but we give it for you for free. Do you want it? Of course, I said, yes, I want it. Then you have to get 1.6 billion baht very quick within 1 week to transport it. Otherwise, it will go away to art university. At that time, we had a very pain. 2 minutes. Okay. At that time, อาจารย์ศาสตราจารย์นิพนธ์นะครับเป็นอธิการบดีwriter. I went up to see him. I said, Rector, I need some money. He said, how much? I said, 1.6 million baht. He said, what for? I want to transport tandem accelerator which costs 90 million baht from Sweden. He remained quiet for 10 seconds. My heart. He said, yes. I said, oh. So I sent the word within weeks. Of course, it came and we assembled it within no time. It is still in use nowadays. Okay? And I have 2 minutes left, so I will wrap up very quick. I have to say that just a few words that since we do not understand ion source, we need to create the ion source. So we need to create plasma. That's why plasma was born in Chiang Mai University, because of we don't understand ion source and we need to create. And this is how we build the plasma. This is the multi-curve plasma. It's very intense because it lines up with magnetic field, cross field line up. It's the second one in the world, And who taught us? Cao Liang from Lawrence Berkeley taught us how to build plasma. Harold Engate, the world #1 electromagnet, came to Chiang Mai to teach us how to build electromagnet, And Ian Ra, I have to mention this because it came to help us build the plasma also. And of course, this is the application that I have no time to tell you now, but the last one that we are trying to do is to build a terahertz radiation. From a terahertz, we are going to build a free electron laser, which someone will tell you about it right now. After this, so I will not tell you about that. Okay, I have to mention that the first use of linear accelerator to treat patients was in Chiang Mai, at Chiang Mai Hospital in 2028. นะครับ2028. And of course, we have now a synchrotron later on, and then will tell us the big idea, the new synchrotron. And of course, you have your particle accelerator and this. And my boss asked me to tell us something about the pilot hub of Thailand electron beam facility and terahertz radiation, which Ajahn Saron is chairing this project. She will tell you something about this later on. Okay. So there are many people, many countries who are involved with the project at the Chiang Mai University. Now we're going to have accelerator at Sulanadi University. We have accelerator at TIN, and we're going to have accelerator at many hospitals, hopefully. So thank you very much.
Thank you.